welcome. Let's get going. Okay, so on page 643, before we look at an example specifically, let's just talk a little bit about an illustration. Okay, let's say that we're at the school, which we are, and Middletown is 5 miles away. Now I know it's not quite, but it's close. Okay, so 5 miles away. If we wanted to go 1/3 of the distance, anytime that we see the word of, that means multiply. So that means it'd be 5/3 or 1 2/3 away from the school. Miles. Does that make sense? So if I want to go 1/3 of the distance, I've went 1 2/3 miles. You guys see that? That concept is what we do over and over and over again today. Is thinking of, all right, from here to here, how far is it? How do we find it? Okay? And a lot of it's working with negative numbers. All right, so that being said, let's take a look at 643. And we're going to look at example B on 643. Okay, so it says that point A is at -4, 4. And point B is at 2, 1. At your seat, go ahead and plot those 2 points there to the right. It's not a real life example, but we're going from A to B. It does have direction, very similar to our discussion when we talked about vectors, where it's got direction. Okay, we're going from A to B. Now it says in the problem that it's in the ratio of 1 to 2, meaning they're trying to find point P, and point P is in the ratio of 1 to 2, which I wrote right here. Okay. Ratio of 1 to 2. Let me help you with this, okay? That means you do this fraction. You just add these two, they go to the denominator. If it's in the ratio of 1 to 2, it is 1/3 of the distance. I'm going to say it again. If it's in the ratio of 1 to 2, it's 1/3 of the distance. Here's the math. Okay, now I'm going to show you how to find that on a coordinate plane. 1/3 of the distance. Going good? Okay, so we know A is -4, 4. We know B is 2 and 1. Do you guys remember the terms rise and run from slope? Do you remember that? Okay, well, we're going to use those again. Hello, you guys done with I-step? Okay, good. We're on page 643. Okay. All right, so now the run is how far it's going horizontally. The rise is how far it's going up and down. Run horizontally, rise vertically. All right, so just look at this. If I'm comparing -4 to 2, how far away are those two numbers? 6 units. Now, if I'm going direction from -4 to +2, is it +6 or -6? It's +6. Maddie, does that make sense? Nod your head if you get that. Okay, let's do the rise then. If I'm going from +4 to +1, how far have I traveled? 3 or -3? -3. Now, you can look at this as a graph, which I'm going to go ahead and show you as well. Here's another way, a secondary way to do this. If I think of, okay, if I start at A, how far across is it? Well, I just told you, that's 6 units. If I start at A, how far down is it? We just talked about that. That's negative 3 units. You see what I mean? So you could look at it on a graph. You don't have to, but you could. And on this one, they have a graph provided. So we're 6 units to the right, and we're 3 units down. Everyone okay? All right. Well, the total distance of P is 1/3. And so what we have to do is we have to apply 1/3 to each the rise and the run. What's 1/3 of negative 3? Just multiply. Negative 1. What's 1/3 of 6? Just multiply. It's 2. Okay, so what does that mean? Is that a coordinate? 2, negative 1? No, that's not a coordinate. That's how much we're moving. Remember, it's like a vector. It's moving. We start at A and we go 2 units. And we go down 1 unit. And there we find P. Now, what's the coordinate? If I started at, let me do it like this. Maybe this is also helpful. If I start at negative 4 and I go 2 units to the right from negative 4, where am I going to end up? What's negative 4 plus 2? Negative 2. Maggie, does that make sense? All I did was add 2. I just moved 2 units over. Now I'm going to go down 1 unit from 4, so where am I going to end up? What's 4 minus 1? There's my coordinate for P. Okay? Well, maybe that's about as clear as mud. Let's do another one just to make sure we know what we're doing. Just to verify our comprehension. Let's go to your turn. It's on the next page. Your turn, number 6. So we're now on page 644, number 6. All right, so the given information is A is 4, 2. B, negative 6, negative 13. And we're in the ratio of 3 to 2. All right, let me pause. Can, do, could, should, possibly do a graph? It's up to you. If it helps you see it, then make a graph. Okay? It's not required. We just did it on part B because I think it might help you right at the beginning here. But you don't have to have a graph. Okay? All right, so back to here. Let's try this one. If you need to make a graph, go ahead. But let's try it together that we're not going to use a graph. All right? All right. The first thing we did, we're going to follow the same pattern. The first thing we did is figure out, okay, if it's in the ratio of 3 to 2, what does that mean? That means it's a distance of 3/5. Remember, we went 3 and then 3 plus 2.
Why do you do that?
That's how you find the proper ratio. Okay? So it's, if I go back to my concept of the school to Middletown, if I divide these into, the 5 miles, and I want to go 1/3 of the distance, how do I find that's 1 2/3 over? And the other one would be, I think, 3 and 1/3. That makes sense?
Yeah.
That's how you find the distance, is you take the ratio and put it over our fraction. Just always works. Okay? All right, so we got 3/5 of the distance. Now we got to find the rise and the run now, and then we're going to use that concept. Rise, run. Doesn't matter which one we do first. No. Just don't get them confused. Remember, the rise is always the y values. The run is always the x values. Okay? Let's do run first. X's. All right. So if I'm going, here's another way, a little hint. Think of a number line. If this is 0, and I go 4, and I go negative 6, if I start at 4 and I go to negative 6, if I start here and I go to negative 6, how far did I go? 10 units. Do I go positive or negative? Negative. All right, let me stop there and make sure everyone sees that. The run from A to B is negative 10. Hope you good there. Okay, let's do the rise. We're still going to look at it as a number line, though. Okay, now we're going from negative 13 to positive 2. All right, so if I start at negative 13, I go all the way to positive 2. How far did I go? 15 units. I go positive or negative? Positive. Garrett, does that make sense? Does everyone see how I found the run and the rise? Or the rise and the run? Yeah. I know, that's what I was just getting ready to verify. Okay, so let's make sure we're going in the right direction. Carter's exactly right. Make sure we go in the right direction. So are we starting with B or are we starting with A? We're starting with A. So when we went 4 to negative 6, which way is that? From 4 to negative 6. That's negative 10. So should we start with 2 or should we start with 13? We should start with 2, shouldn't we? If we're going from 2 and going the other direction, then we actually went negative 15. Everyone see that? It's always good to verify. Make sure you got it right. Maggie, we good? You good? Okay. Now, all this tells us is how far we've moved. How far is point P, though? Point P isn't the whole way. Point P is only 3/5 of the way. I know, you got to work with fractions. Use a calculator if you have to. Okay? So we want to go 3/5 of, anytime we use the word of, that means multiply. So if I want to go 3/5 of negative 15. Use a calculator if you can't do it. Otherwise, just multiply or reduce. 3/5 of negative 15 is? Negative 9. 3 times negative 15 is negative 45. Negative 45 divided by 5 is negative 9. Okay? We'll do the other one. 3/5 of negative 10 is? Negative 6. So now this is our run, and this is our rise. That's not where we've ended up. That's just how much we're moving. Okay? So if we start with point A, which is at 4, 2, and we're moving on the run, negative 6. What's 4 minus 6? Negative 2. And what's 2 minus 9? Thank you, Bo. And he's exactly right. And so where do we end up? We end up at the coordinate of negative 2, negative 7. Questions? All right, again, that's a little different because we didn't graph it, did we? And if it's a little easier to graph, then go ahead and graph. Let's give you another chance. Do your turn number 5. Right next to it, at your seat. Your turn number 5. Follow the pattern that we just did. Do it at your seat. Your turn number 5. First step, for those of you that are stuck, what's 5 to 3 mean? It means that it's 5 over 8. That's your first step. You just add 5 plus 3. Put that in the denominator. Next thing we have to figure out is the rise and the run for each. All right. What's the rise and the run from negative 6 to 2? Let's do the run first. So negative 6 to positive 2. How far is that? Well, how far is that? Positive 8. I agree. Bella, you see how we're getting that? Isabella. Ella. What all do you want me to call you? How do we do the rise then, Ella? What do you get from 5 to negative 3? That's right. No, very good. All right, now we apply the distance of it, which is 5/8. Reduce, that's negative 1 times 5, which is negative 5. That's how far we're moving along the x. And reduce here, what is that? Positive 5. Now, that's not our coordinate or anything. That's just how far it's moving. So we go from point A. You still on the screen? Yeah. From point A, which is negative 6, 5. And our run, we're moving positive 5. What's negative 6 plus 5? Very good. And then what's 5 minus 5? That's our coordinate, 1, 0. Few steps. I don't think any of the steps are real difficult, but you got to keep them straight. Okay? And you got to work a little bit with fractions. Let's do one from your homework just to make sure that we're okay. All right, so take a look at number 2 on our homework, which is page 646. What number? Number 2, 646. It says we got dancers that are in the coordinates of 5 to 23. So I'm not going to draw the dancers, but there is dancer A at 5, and there is dancer B at 23. Almost like on a number line. Okay? Micah, does that make sense? Okay, then it says dancer D, we're looking at number 2. Dancer D stands at a point that is 1/3 of the distance. They're already telling us that's 1/3 of the distance from A to B. Again, it gives us direction from A to B. Well, what's the total distance from 5 to 23? How far apart are those? 18 units. Lily, does that make sense? 5 to 23 is 18 units. Well, if this is 1/3 of 18, it's just a multiplication problem. That means it's 6 units away. So if I'm starting at the coordinate of 5 and I'm going 6 units, where am I going to end up at? 11. So dancer D is at coordinate 11. Garrett, you got it? Kylie, does that make sense? Now that one's a little easier because we didn't have to do both a rise and a run, right? We only did the run. We only did the horizontal. Okay? But they're all about the same now. All right, so your assignment is page 646. We're going to do 1 through 16. Before I lose your attention and you start working, here's a couple things I need to clarify. A few of the questions have to do with constructions. You're welcome to use a compass, like we did in class on Friday. Okay? But you don't have to. You can just do it freehand. Meaning, if they've got this and they want to divide it into 4 equal spots, I don't know if you remember or not, we go 1, 2, 3, 4, then we connect, draw parallel lines. We did it on Friday. If you don't remember, watch the video. Okay? We just used the compass to do it. All right? So there's a few questions that do that. And you're welcome to do it freehand. I'm okay with that. As long as you know the concept. Okay? All right. 30 minutes. Yeah, you got about 20 minutes here to you should get close to getting done. All right, let's get to work.